Tomorrow is the 50th anniversary of the launch of Apollo 12, which was the second moon landing that people forget. Everybody remembers Apollo 11. You know, the last July 20th was the 50th anniversary. But tomorrow, and it was the weather kind of like this, they lifted off. These three guys took off to the moon on November 14th, came back November 24th. They were the third and fourth men to walk on the moon. And this crew, they're all dead now. A lot of the Apollo astronauts are leaving us. There's only 4 moonwalkers left out of the original 12. And this is the Saturn V rocket that took off a couple hours north of here. Still today the most powerful, largest rocket ever built, most successful. It took off in a rainstorm and actually was struck by lightning on the way up a couple times on the launch pad. Anyway, a couple days later, they get to the moon and they land near this spacecraft, a robotic spacecraft called Surveyor 3, that landed 2.5 years on the moon before they got there. And this mission was going to try to prove they can do pinpoint landings on the moon. You can see they did a real good job. They landed 600 feet away. And then once they got there, one of their objectives was to go over to clip off some of the parts of the spacecraft that had been on the moon for 2.5 years and bring them back to study, to see how equipment and structures hold up in the lunar environment to help prepare for if we go back and live on the moon. And so this is pretty neat because this happened on my birthday when I was just turned 11 years old. I remember this, and that's Alan Bean, who I got to meet several times later. And so Apollo is important, and Apollo is our only experience going to another planet. The moon sort of is a planet. I think talking about a solid surface object. It's the only time we've done this, okay, and it's 50 years ago. The last time we did it was in 1972. So it's important, in order to know where you're going, you got to know where you came from. So that's why I kind of mentioned that. Now, going on to Mars, we're kind of just ending, if you want to think of it, the first wave of Martian exploration with our rovers on the surface. We started out looking at Mars through telescopes, obviously, and it attracted the eyes of the ancient civilizations because it's kind of a reddish color and it's associated with the god of war. You probably already know all this stuff. The reason I put this up there is if you took all 7 continents on the Earth and squeezed them together, that's how big Mars is, okay? A lot of surface area to explore. If you take just the continent of Africa and squish that, that's the moon, okay? So that's kind of a neat way to remember the sizes of these things and to give you an idea and appreciate how much area there is to explore there. The moon, we landed on 6 different places with astronauts. And so it's fair to say we don't really know all about the moon. Now, Mars exploration, the common denominator here, the common thread is water. And I think you've probably learned about that in your class so far, that water is crucial. Water is the quintessence of life. There's no life forms on Earth that can exist without liquid water, maybe a microfilm or maybe gallons of water, but you have to have liquid water in a liquid state. So as the first line up there, life and water, is pretty obvious. Water and climate, it's pretty obvious because water drives climate, creates clouds and things on Earth and also somewhat on Mars, although the Martian atmosphere is pretty simple compared to what we have here on Earth. I'm a geologist. You're probably thinking, how does water play in with geology? Well, a lot of ways. Certain minerals only form in the presence of water, okay? And we found these minerals with our rover, so we know there were ancient lakes on Mars, okay? And there are certain canyons carved out by ancient floods on Mars. There's landforms. So water is very important with geology. And human exploration is what you're talking about this semester. I think you all know that water is crucial for that. And Mars has water. And this picture here, you can see the north polar cap of Mars, and that's all water ice. Now in the lower latitudes down to around 30, 40 north, the same thing's true as you head south, there's ground ice on Mars, like on Earth, permafrost. Now if you get up there and dig, if you're closer to the pole, you dig shallower distances to get to the ice, okay? But if you get in the mid-latitudes, 30 to 40 latitudes, north and south, you may have to go down maybe a meter or so, but under that there's ice in the ground. And that's your big resource. Water is the most valuable resource in space exploration because you have to have water to live, okay? But you break water apart, you probably know this, you can make liquid oxygen, liquid hydrogen, rocket fuel. That was what's in the orange tank of the space shuttle when it used to fly. You probably remember that. And that orange tank was all liquid oxygen, liquid hydrogen, rocket fuel. Also, if you break that water, melt it down and filter it, you got drinking water, and you can split off oxygen to breathe. So that's the most valuable resource, more valuable than gold or diamonds or platinum. It's a simple thing like water. Mars has it abundantly, and we know it's in the ground. We've landed a spacecraft called Mars Phoenix up around 70 degrees north back in 2008, dug down about 4 centimeters and hit ground ice. Okay, so we know it's there. Now, as you get down to the equatorial areas of Mars, it's probably there, but it's maybe under kilometers below the surface because it wouldn't, and liquid water is no longer stable on the surface of Mars today. The pressure is too low. But we know it used to be there in the past because we see all the ancient river canyons. Mars is a dangerous place to go. It's called the graveyard of the solar system. It is the most difficult planet to explore. And I forgot the number now. I think the total is approaching 50, and 2/3 of those missions have failed. The United States has had the most success, but we've had some failures. In terms of landing on the surface, we're the only country that's ever done it. We are 8 for 9. And we have another rover fixing to take off this next summer, between July and August. And it's going to land on Mars on February 18th, 2021. And how do I know that exact date? Because of orbital mechanics. On February 18th, 2021, we're either going to land on Mars or make another crater on Mars because it's coming in. There's no two ways about it. This picture here is from a cemetery in Birmingham, Alabama. And it's kind of eerie looking, but Mars is a tough place. And there's, in the 60s, flying out to Mars, before you got there, there was something called the galactic ghoul. It was just talk. There's no ghoul out there, but always the spacecraft would disappear. I think it's a joke, this thing would eat the spacecraft up. The Russians/Soviet Union have never had a successful mission to Mars. They tried about 25 times, all failures. And and this coming up summer, a lot of countries are going. The United States is going. The Europeans and the Russians are hoping to go if they can fix their parachute problems. The United Arab Emirates is going for a mission called HOPE. And China is planning to launch a lander, orbiter, and a rover. So we'll see if they all get there successfully. But it'll be a busy place. Now, a little history. This was the first picture returned from Mars in 1965 from a spacecraft called Mariner 4. And at the same time, we were exploring the moon, getting ready to send Apollo astronauts there. And when this picture came back, it looked a lot like the moon because all you see is craters. It looks kind of boring. I'll tell you, when this mission was launched and before it took this picture, there were still scientists talking about possible canals on Mars. Okay? It's a possibility of life on Mars. And when this picture came back, it kind of blew those theories. They were gone for good. Not many people thought that, but they thought it's possible. Maybe there is something on Mars. Well, when these pictures came back, it looked pretty desolate, just like the moon. It's like, no water story here, no life story. It's just, a bunch of craters and pretty boring object. Several years later, Mariner 6 and 7 flew by Mars, and these are flybys. They did not go into orbit. They just zoomed by the planet and clicked off pictures. This was in August 1969, about 2 weeks after the Apollo 11 first lunar landing. And it kind of got lost in the attention of the moon landing. Once again, you look at it, it's just a bunch of craters. It looks a lot like the moon. But something is in here that was missed at the time. And I can see it now because I have 20/20 hindsight. Down here, these are some of these things called valley networks, dried river systems. And you got to wonder, because you get preconceived notions in your head and it's dangerous, okay, especially in science because you miss things. At the time, most of the conventional thinking of Mars, wasn't any water there. It's just basically a crater-scarred object like the moon. But there it is down there, and no one really picked up on it because you can't really tell what it is. The resolution is not very good. I know what it is now because we got better pictures of the same area, but I got the benefit of experience and a lot of missions that flew. Now, this is 1969, and our view of Mars is, man, it looked good in science fiction, but it's really a disappointment. When we sent a spacecraft there in 1971, in November of 1971, called Mariner 9, it gets there and there's a giant dust storm going on Mars. So the planet is covered in dust, and you can't see what's going on. But this mission orbits the planet, stays in orbit. It's the first mission to ever go in orbit around Mars. Now, you see this, and you're thinking, so it's bright and dark bunch of stuff, and these are like dust specks on the camera lens. It's kind of a crummy picture. But what they're looking at here, when the dust clears some months later, this giant canyon system called Valles Marineris. It stretches the length of the United States. It's the biggest canyon. This is the real Grand Canyon of the solar system. This is just a portion of it. The Grand Canyon in Arizona, where I live, might be one of these little squiggly things right there. And so when the dust settled, literally, on Mars, things changed. And those missions that flew by before, in 1965 and 1969, they happened to go over the cratered part of Mars in the southern hemisphere. If they would have gone over the other parts, our whole perspective of Mars would have changed. And if they would have got this picture, we may have been on Mars right now. because this picture came back from the Viking spacecraft. These are the dried river channels. It was just happenstance of orbital geometry. When we flew by Mars, we didn't see this with those early spacecraft. These things would have shown up. And this shows Mars looking a lot like early Earth. I did my master's thesis on this channel here, mapping it. It's called Majah Vallis. These are old river canyons, okay, billions of years old. And you got to wonder if these pictures came back in 1969, would the president have said, man, we're definitely going to Mars now? Because the plan was to go to Mars by 1981. Maybe we would have been there by now. These are some pictures from other spacecraft that this is currently in orbit called the Mars Reconnaissance Orbiter from the high-rise image. And the resolution on this thing, you can see this disk on the surface of Mars down there. You can see 25 centimeters of pixel resolution. You need about 3 pixels to make out detail. But these are small features. You can imagine walking across that scene right there. And you're looking down on these rock outcrops. They're layered. You can see the layers here. These are all sand dunes down here. And a couple eroded craters and stuff. So looks a lot like out in Arizona, a lot of these landforms. This, you know, have a clue what this is? Remember, you're looking down like a bird's eye view of the surface. Yeah, exactly. It's a dust devil on Mars. And you can see here it's twisting off. If you've ever seen a dust devil, you're not going to see him. You might see a water spout if you're lucky down here, but out in Arizona, you see dust devils all the time. Yeah, that's a shadow right here. Exactly, the dust devil. And this is also the path it took clearing off some of the dust, but some of the shadow you can see. And these things are very common on Mars in the mid to late afternoons, especially in the summertime. So Mars is looking like a kind of familiar place, kind of different, but very familiar. This is a picture from orbit of about 200 miles above the surface. And you can see the tracks of the rover I worked on here, coming in here. This is part of a segment of a crater called Victoria Crater. And there's our rover right there sitting on Mars. And the rover's the size of a golf cart, solar powered. And you can see rock layers in there. We spent about a year and a half exploring this crater. And this just shows you all the places we've landed on Mars successfully so far. The mission that takes off this summer is going to land about roughly somewhere in here, a place called Jezero Crater. But these are all the successful landings on Mars, and they're all by the US. We were the only countries being able to do it. I worked on a mission. I told you we were 8 for 9 for landings. I worked on a mission, can't see it here, but in 1999, I guess it's going to be 20 years ago next month, we were supposed to land near the South Pole of Mars, but it crashed. And you know, when things crash on these projects, you don't hear about how it affects people that work on it, spend years of their life. You lose your job. And so this kind of career is not for the faint of heart. You have a question?
Yeah, I don't know if they're safely ended though. Is it okay to ask now?
Yeah, go ahead.
Well, you were just saying that was solar paneled, and we talked a lot in this class about like how reliable having solar powered things are.
Mm-hmm.
Like, because we were talking about like, what if there is a dust storm and it literally happens for months and you're just at a commission? Like, do you guys just deal with that? Or?
Yeah, well, when you send people to Mars, you're not going to rely on solar. You'll use it as to augment your power, or like a supplement, because it's free and it's there.
Right.
But you're not going to depend on that 100% of your power. You'll have nuclear reactors.
As a back, okay.
And solar can be used, and it will be used, but you don't want to use it for the exact reason you said. These dust storms can last months. Yeah. And that's what killed Opportunity when it died after 15 years. The dust was so bad. And these global dust storms, they're nasty. They happen in Martian summer, southern summer. Okay, that's when its southern hemisphere is closer to the sun in its orbit. That's when they kick up, but they don't happen every time. And you got to remember, Martian year is equivalent to about 2 Earth years. Okay, because it's further from the sun, it takes longer to go around the sun in one orbit. So Mars has seasons that are about twice as long as they are here on Earth, because the year is about twice as long. So Mars has a fall, winter, spring, and summer. It's always cold up there, though, you know. And so the dust storms, you don't want to rely on that for your astronauts because they could die. And when you have people there, you're going to need a lot of power, you know, to keep them alive. So you're going to have nuclear reactors. I think the number they're talking about is around 40, 50 kilowatts. And depending, if you have more people, you're going to need more, but it's a starting point. And of course, you'll have solar, probably lay out like solar farms, you're going to call them, the panels everywhere. But you got to keep them clean.
Yeah, you have to keep them clean.
And it's not that simple, because you go out there for a rag and keep them clean, that scratches the solar cells up. the abrasion of the dust. The dust on there is like the particulate matter in cigarette smoke. It's microns in diameter, okay? And when you try to clean it off, you're scratching up all your germanium or whatever your solar panels are made of, ruin them. And you ruin them because then they're gonna get all scuffed up and they're not gonna get any sunlight through there. So it's not simple. And people asked us, how come you didn't clean the panels on your rover? You know, the reason these rovers were only supposed to last 90 days was we thought the dust would accumulate on the solar panels, because it's always raining out of the sky. And enough would get on there, it would attenuate sunlight, and we would get enough power, and we'd basically die, freeze to death. What we didn't know about the dust devils. We knew there were dust devils, but we didn't know they would come by and suck the dust off our panels. And winds, when you get near mountainous areas, winds would blow it off. And so that's why one reason we survived so long. Another reason they were designed, they were great vehicles. But we had a great team we worked on to keep them alive. But yeah, the dust is an issue on Mars, and there's no way around it. You'll have dust on the moon if you go there too, but it's not going to blow in the wind because there's no wind on the moon. So that's a big issue. And so your power is going to come from nuclear reactors when you get people on Mars, because you're just going to need that. If you start melting this ground ice for your water and rocket fuel, it takes a lot of energy to do that. You know, and if you try to break down rocks to get irons and things out of that, smelting or whatever, that's a lot of energy too. So you're going to need that. You can't do that with solar. And but there will be solar there. But the movie The Martian, y'all see that movie?
Yeah, we watched.
So that's a pretty good movie. But the whole premise of the way the movie starts is all BS. The winds don't blow like that on Mars, okay? They don't blow people and equipment around. Like that whole thing was just pure Hollywood garbage. Well, I tell you, I know because we've been through several dust storms. And we saw a couple sand grains move. That was it, okay? And you hear wind speeds of 100 or 200 miles an hour, that's true. But the dynamic pressure of the Martian atmosphere, because it's so thin, that would feel like about a 20-mile-an-hour wind on here on Earth to us. Because the atmospheric pressure on Mars, do you know what that is? It's almost nothing. Like here at sea level, it's about 1,000 millibars, 1,018. On Mars, it's about 10 millibars, okay? And that's equivalent to about 20 miles above the surface of the Earth, okay? And that's, the thing about Mars, it's got atmosphere, just enough of atmosphere to be a problem for landing and all these things. But it's almost nothing there. And that's why you have to have a heat shield and parachutes and all these things. You know, parachutes won't work on the moon, obviously. So Mars is a tough place to land. And, but it's, you know, we've done it. And we're going to do it again in February of 2021. But the big question is, when are we going to get people up there? And that's hard to put a date on because we don't know. I mean, it's been talked about for a long time. This was the first successful landing on Mars, called Viking 1. I see you've got some pictures of Viking right there. That's the first photograph to ever come back from the surface of Mars. I was 17 years old. I remember when that came down, line by line. I woke all my brothers and sisters up early in the morning to watch it. And my sister said, when history happens again, I'll watch it on the 5 o'clock news. She didn't want to get up early. But I remember, this is part of that picture right there. And yeah, that was really a neat time. And you can see that Mars looks nothing like the Mars of science fiction with canals and all this kind of stuff. Then the last time, so that was 76. We didn't go back to Mars till 1996, you know. And so a lot of time passed because people were disappointed in Mars. This Viking mission, I'll go back to it, is perceived by some as a failure because it was the only mission to this day that had biology instruments on it. There are 3 biology instruments on this lander. And this is the arm that would reach out and scoop up Martian soil. You can see it's got a couple scoops right there. This with your weather station, measuring your wind speeds and direction and temperature. And this vehicle is powered by nuclear reactors under these wind screens right here. And these things lasted about 7 years on Mars. So when a dust storm came, it didn't matter. Who cares? We got all the power we need. And the Curiosity rover that's on Mars right now, and the rover that's going to go there in 2021, that's nuclear powered. So we don't care about dust anymore on Mars. It's going to mess up our cameras and pictures are hazy, but we still get to do work. Anyway, this mission was perceived as a failure because it didn't find life on Mars. Well, people forget science isn't, science, when you find out something or you're incorrect or you're wrong, that's progress because that's a possibility you've eliminated now. You can move forward from that. Our society perceives failures as bad things to avoid. That's not the way science progresses. If you look at the history of science, and if you're an engineer, you know that's not the way things progress. You got to test things, they fail, and then you make modifications and you learn from those things. So the fact that we found no life on Mars left a bad taste in a lot of people's mouth. That's why we didn't go back for almost 2 decades. We learned so much about Mars from these missions. We landed two missions there, Viking 1 and 2. The other one was in September 3rd, 1976. We had 2 orbiters mapping the planet. We could see things the size of a football field and map the whole planet, polar caps, dunes, canyons, dried riverbeds, volcanoes. Great mission. And the biology results, there were 3 instruments, as I alluded to, and it just so happened it worked out this way. One of them was a gas chromatograph mass spectrometer. It was looking for organic compounds. We cannot fathom how you can have life if you don't have organic compounds that we're made of, carbon, hydrogen, nitrogen, phosphorus, sulfur, all this stuff. Couldn't find any of that in soil. So that biology experiment was big O X, no signs of organics. It can't be life. Another one came back, it was kind of ambiguous. The third one came back and said, there is life on Mars. So what do you do with that? So the one that got positive signs was called the labeled release experiment. And what they did, they took some Martian soil and they took it and they dumped it through a little funnel. You can't see it on top of the lander deck. And it would go down to the instruments in the belly of the spacecraft. The labeled release had something they called chicken soup. It wasn't, but it was like a nutrient. They squirted it on the soil. And it was laced with radioactive carbon-14. And the thinking was that if there's anything alive in Mars, it's going to gobble this stuff up as food. And then we're going to heat it up and kill it. And the carbon-14, which is laced in there, will be detected in our instruments. They did this, and sure enough, they heated it up. It did it before that. They did one time not heating it, and another test heating it up. And it went away when they heated it up because it would have killed anything alive in there. And they're like, man, this is the ground rules. This is a positive sign of life. And also oxygen levels went up in there big time. So this guy, he's still alive. His name is Gil Levin. He, to this day, thinks he discovered life on Mars. The science community doesn't think so. There are some other people on this team that said, this guy's out of his mind. There's no way it's wrong. To this day, that result's still out there. We're not sure. It's going to be really funny if we get to Mars and find out the guy was right. We discovered life in 1976, but ignored it, kind of. But it's hard to do because the 3 instruments, what do? One's positive, one negative, and one is kind of like, not sure. The way it worked out. But that set Mars exploration back in a way because most people thought, here we go again, Mars has fooled us. We thought it was going to be interesting for all these dried riverbeds and canyons, and now we get there and there's no signs of life. So what do we get? People didn't want to get fooled again. This mission went there, landed in one of these outflow channels, and didn't have any biology instruments, but it started showing that there was water that went through here, a lot of water. I won't go through all this, but this is kind of like where we are now. These spacecraft are all working at Mars. Opportunity quit working last February. Curiosity's going. This rover got pushed to 2020. This is the European Mars one. And this is the one I'm talking about February 18th. So there's going to be 2 rovers, maybe 3 if the Chinese get theirs down there in actually it'll be 2021 when they land on Mars, but they lift off 2020. And this is the state of Martian exploration right now. And you don't see anything about people in here yet. But you see, early on, it's follow the water. And another thing here was kind of follow the carbon, to see if there's any carbon organic materials. And we have discovered organic material on Mars now with Curiosity rover. So the organics are there. And actually, you'd be surprised if there weren't organics because organics fall out of meteorites all the time. And we found meteorites on Mars. So to me, it wasn't a surprise when we found organics. They should be there. It'd be more of a surprise if they weren't. So this brings us to the rovers I worked on. And this was like a next phase of the first historic overland exploration of Mars. We did it for 15 years. My office was on Mars for 15 years, working on these rovers. And this is Spirit and Opportunity, twin rovers, the size of a golf cart, solar powered. These are the solar panels on top of the flight deck here you can't see. I won't read through all the instruments because I know you can look at them, but this thing here, we call it the arm. It's the instrument deployment device. It's about the size of a human arm. It has a shoulder, elbow, wrist joints, and a set of fingers, has little instruments out there. And these are just fantastic vehicles. We could drive them forwards and backwards, flip the cameras around. So the engineers did a great job building these things. And we developed a philosophy. It kind of just happened. We didn't sit down with a piece of paper, here's our philosophy on this mission. It just kind of evolved. And it was great because it starts with leadership. And good leadership rolls downhill. And everybody was there for a purpose, the science and engineering teams. We were not a bunch of individuals trying to get our own publications out or whatever. we were a team, and our team goal was to explore Mars the best we can with the hardware we're given to do it with. So that's kind of what we all thought. Because I'll tell you, in space program, engineers and scientists are like this. They usually butt heads. They do not get along. They have different ways of thinking and doing things. And a lot of the old timers, the Jet Propulsion Laboratory, which is like the mission control for unmanned missions, the robotic missions in Pasadena, California, would come by and marvel at our team. They said, I've never seen a team get along together like y'all. And it started with the good leadership at the top. And we took every day as a gift because tomorrow's not guaranteed. One of our sayings was like, we're doing field geology on Mars with these rovers, but there's a sniper on the hill. And one day, he's going to get us. Luckily, his aim was pretty horrible because we lasted 15 years. We were only supposed to last 90 days. And like I said down here, the scientists learned to think like engineers and vice versa. That helped the morale of the team and stuff. So I did this for 15 years, and it was an adventure of a lifetime. And I don't want to go through all this detail because I know we got a lot to talk about, but one day we spent 2 years training how to operate these vehicles. And if you didn't go through what we call flight school, you'd not be allowed in the control room the days we landed and operate the vehicles. So you had to go to flight school at JPL. One day a senior scientist at lunch said, you know, I've been looking at the timelines, and if you do it just right, you can work both rovers. Because most people were picking one rover, work Spirit or Opportunity. They were on literally opposite sides of the planet. And so when one rover's awake, the team can sleep and get rest. And I said, I'm interested, tell me more. He said, well, you're not going to get any sleep, but you can go to make all the critical meetings, do everything. I was the only one on the team that did this. And to this day, I'm so glad I did it because I lived on 4 hours of sleep for about 5 months in 2 2-hour blocks. But I know myself, and I wouldn't have slept anyway. Because when I'm home, we had apartments they rented for us out there in Pasadena. I'm there thinking, pictures are coming down from Mars right now. I wouldn't be asleep, so I just stay there. I work both rovers. And when one team was asleep, I would say, when y'all guys get in the morning, check these images out. Look at this, look at that. So I got to see these things for anybody else. It was a lot of fun. And I figured I'd sleep when I'm in the grave, you know. And we lived on Mars time, which is another story, from January to almost May. And that was interesting. But I got lucky because the meeting before the night we landed Spirit, which was the first rover to land on January 3rd, 2004, we had an all-hands meeting. We're breaking up, and Steve Squires was our science team leader. And I said, Steve, you know, we got rovers. We're going to be covering territory. What are we going to name things? Because we're going to see hills, canyons, craters. Who knows what we're going to see? He said, I don't know, Rice. You're in charge. So I said, okay. So my idea with all the craters where Opportunity landed, Meridiani Planet, were going to be named after famous ships of exploration. And the first crater we rolled into is called Eagle. Anybody know what famous ship that was? It's Apollo 11 lunar module, Eagle. So if you look at all the craters in Meridiani, they're all after famous ships of exploration. James Cook, the last crater we got to is Endeavour. That's his big ship. So there's a Santa Maria on there and all this. In Gusev Crater, where Spirit landed, we named craters that we came to after ancient paleo lakes because some people thought there was going to be a lake in Gusev Crater. And there was, but it was under all these lava flows. Anyway, so I told you, Spirit ended about 2010. It lasted about almost 7 years, way longer than it's supposed to. Opportunities ended last February. And it's weird because, in a way, I still haven't gotten over it. For 15 years, I got selected on the team in 2002, so 17 years. These were things I worked. These rovers are like my friends on Mars, doing work that I would be doing if I could be there. And they're not humans, but there's a weird attachment to them. And I still can't really explain it fully. Every morning I get up and turn my computer on thinking I can see pictures from Mars, but it doesn't happen anymore because I did it for 15 years. That was one of my jobs, is to analyze the pictures and to tell which pictures to take and where to tell the rover to go. And when that goes away, you just, after doing it for so long, you get withdrawal symptoms. And it's a weird thing. And these are pieces of metal and titanium and silicon, but they're like friends. It's weird. I just can't really explain it. And so anyway, going to some other things, whenever you fly a mission, you have to have goals and objectives. Those are sometimes get intermixed. But you have to know this, and you should be able to do it in a sentence or two if you want to be generous. If it takes more than that, you don't know what you're doing. You're not clear. So I had a question for y'all now. So in the project you're working on, what was your primary goal or objective for your study this semester? Did y'all figure out what the main goal was? Is it just to put people there, or what?
Yeah,
You-
it was a lot of different things. Like we really were just trying to problem solve a bunch of different subjects. Like we're looking at plants and looking at greenhouses,
Mhm.
habitat modules, like a ton of stuff.
Okay, yeah.
So essentially, the long-term goal is to arrive there successfully and sustain ourselves successfully long-term.
Right.
How to do that.
Now, was this going to be the first Mars landing, or it wasn't defined which one this was in order or anything?
It was like the first human Mars landing.
Okay. And the plan was to stay there how long on the surface? Did that?
It was like about a year, maybe.
And what's the reason a year?
To get as much scientific information by human hands as possible, because rovers are a little bit limited in what they could do, but scientists theoretically, like human scientists theoretically, could do a lot more.
Yeah, you're right. Absolutely right. But what about orbital mechanics? Does that dictate how long you're going to sit at Mars? Yeah. And that's the thing about Mars is it makes it kind of tough, because once you get there, you can't just decide to come home. You got to wait for the planets to realign to come home. So you're committed, you know. And okay. And well, this was our goal for MER, was Mars Exploration Rover, Spirit and Opportunity Project. It's a long sentence, but it's one sentence. Determine the aqueous, climatic, geologic history of 2 sites on Mars where conditions may have been favorable for the preservation, evidence of biotic or prebiotic processes. That was our marching orders. That's what we were sent to do. And we were able to do them, and both rovers. And it was amazing to work on this project. I mean, it's about water on Mars, okay? And now, if you look real close, you see this is in French. It's hard to find a Mars bar in the United States for whatever reason. When I was a kid, you could, but it's hard to find them nowadays. Have you tried to find one lately? I know in Arizona, I can't find them.
They just kind of show up in like big candy bags.
Maybe. But I don't know why that is anyway. But and for your project, did you determine where you're going to land and why? You picked a certain site? Was that part of one of the exercises you had to do? What's that? Because this is critical, okay? This is critical before your resource, if the water is going to be there or not. And if it's there, how deep down you got to go get it. You're sending people there to do good science. You got to have good science in the area to get to. You don't want to land on some, basically tabletop of lava flows. That's going to get boring pretty quick. You want to analyze the lava flow. It'll be some good information, but that's going to be restricted your amount of science. You want to maximize your science and have a lot of different terrains there, or what we call compact geology, a lot going on in a smaller area. So landing site selection is critical, and we spend years doing this on these missions. For the rover that's going to land in February 2021, we spent 4 years deciding which landing site to go to. It's a long, grueling, detailed process. And when people go, it'll be even more so. And you'll see it's very critical, because this place you land, especially with people involved, it could mean the difference between life and death. I've kind of already shown that. And we kind of alluded to this earlier. There's only certain times of the year or years you can fly to Mars. How often can you fly to Mars? Anybody know what the number is? Magic number? 26 months to be exact. Close to 2 years, yeah. That's the way the planets line up. Now, this is based on propulsion systems we have today. If one of y'all go out and develop a nuclear rocket engine, very efficient, we can forget this stuff. We can go to Mars anytime we want. But that's not a capability we have today. A nuclear thermal rocket that can, really crank out massive speeds and get us to Mars. There's something under study, but it's got a long way to go. There's an astronaut working on it, former astronaut Franklin Chang Diaz. It's called the VASIMR, V-A-S-I-M-I-R engine, and that stands for Variable Specific Impulse. It's a magnetic kind of, there's not a nozzle in the rocket engine, it's a magnetic field that fluctuates. It's a nuclear reactor, okay? Spits out highly charged temperature like xenon gases and stuff. And if you could get this thing to work, you could get to Mars in 40 days. It's a game changer, but there's a lot of ifs in there. That we don't have a giant nuclear reactor big enough to fly into space, and it's a lot of work needs to be done. This is not going to happen by next week, okay? It's a long time from now. But if one of y'all can develop something like this launch window stuff, the home and transfer orbits, it's garbage. You ain't got to worry about it no more. But until that, we do get that, you're dictated by these home and transfer orbits, minimum trajectory orbits, conjunction and opposition class missions you probably talked about. So that's what we're stuck with. You go to Mars every 26 months. For us, back in 2003, this was in June and July, a couple hours up the road from here. That's Spirit at daytime, Opportunity at night. And in 2003, you probably don't remember because some of you weren't thinking about Mars in 2003. That was the closest Earth and Mars had been in 60,000 years. Okay, so we took advantage of it and sent 2 rovers. Okay, the prime time to go. And so the last time Mars was that close to the Earth, Neanderthals were still living down here. Okay, and that distance was about, I think at the time, it was like 34 million miles. So it was a great opportunity to fly to Mars, and we did that. And Spirit landed in a place that was pretty boring. It was a lava flow on the plains. And we saw these hills off in the distance. They're called the Columbia Hills. And if you know anything about geology, geologists like to go in dangerous terrains, canyons, craters, these kind of flat tabletop stuff is usually pretty boring. You want topography to expose your geology. When we got these hills, and these rovers, like I said, were only supposed to last 90 days and only supposed to drive about half a mile, okay? These things were 3 miles away. So we saw these, and we were like, man, that's where we need to be, because this is, once we analyze these rocks, it's all basalt. We call it the basaltic prison. That's all that was around it is basalt. Busted up lava flow from impacts. And we made it to these hills, and it was named after the Columbia astronauts who died on February 1st, 2003. And it just so happened there were 7 hills there, 1 for each crew member. Interesting how it worked out. So we can see our path. We landed up here and went and explored that crater. And the reason, anybody have a clue why we went to that crater up there? I don't expect you to know, but just see if you, yeah. No, well, the reason we went up there is because there's a big empty river channel that flowed into this crater. So the thinking is the water went in there and there's a crater, like a big bowl, and it filled up, it probably was a lake. Well, there probably was a lake, but what people didn't realize is that on top of that, the lake beds, there's all these lava flows that cover it all up. And the lava flows, who knows how deep they go, the thickness of them. And somewhere down there are lake deposits. We didn't know how far. So the thinking is if go up here to this impact crater, because impact craters are like natural drill rigs. They excavate into the subsurface and throw that material out and eject it. So we're thinking, it's not a big crater, but it's the biggest one in the nearby region. Go up there and look at it. And it was about 10 meters deep. And it was still lava flows in there. So we're like, it looks like far, because we couldn't do any drilling deeper than that. So it looks like if we don't see anything interesting, this is all the same stuff out here. And these hills are over there. And once we got those hills, the mission changed. Because it was like a switch was thrown on. It was all the interesting geology. And there's enough time to talk about all of it, but the biggest discovery Spirit made was this white stuff. And you can see it really stands out against the Martian kind of cinnamon-colored soil, the regolith. And what that is, it's 92% pure silica. Now, the only way you can get that is to have heat and a lot of water cooking the rocks for a long time. Basically a hot spring, okay? So if you've ever been to Yellowstone, seen old Faithful Geyser, that mound is all made of silica. It's called sinter, S-I-N-T-E-R. And so what was going on here several billion years ago was hot springs and fumaroles going on, like a Yellowstone. And this silica is perfect for entombing any microscopic organisms, preserving them. Now, we don't know if they're in there because we were a geology mission. We don't have any biology instruments. But you got to wonder, and all of us do wonder this day, if we got a sample of that back, could we find microscopic fossils in there? Don't know. But that environment is where you'd want to go look, because we know a lot of the thinking now is that life on Earth started at these hot spring areas, on the surface or maybe under the seafloor, the black smoke vents, same thing. Now, this picture here is from the last time we walked on the moon, Apollo 17. And there was a geologist, the only geologist who went to the moon, named Jack Schmitt. And this is, like I said, December of '72. And around this crater called Shorty Crater. And the astronauts are out there doing their work, getting their samples. And you can see all the footprints here. They scuffed up the ground. And it revealed this orange soil. And totally by accident, serendipity. Same way we got this, because a busted up wheel drug across this and exposed it. Otherwise, we would have never seen it. That's part of science, the serendipity of it. This stuff on the moon is a similar type story. These are probably like fire fountains going off here. And that was a big discovery at the time for the Apollo mission. But it's interesting how you just happen to scuff up the ground and find this stuff. Otherwise, you'd never known it was there. Going to opportunity quickly, we landed in Eagle Crater, way up there. You can barely even see it, and drove down to Endeavour Crater and did our work there. And that's where we died. And let's see. We go through these pretty quick. We, as a geologist, you look at the rocks, an outcrop, and that's like a history book. The older rocks are at the bottom, the youngest at the top. And if you study the structures in the rock, like cross beds and layering and stuff, you can start putting together your geologic story. And this area here was where we found the old lake beds and stream deposits, and down here were old lithified sand dunes. So we're starting to build this water. So Mars was a lot like Earth early in its history, bottom line. That's just a neat picture of a crater we call the Spirit of St. Louis crater. This rock here is interesting, and you probably think it's probably, all right, boring slide, go to the next one. Well, it's a pretty interesting slide. This tan-colored rock here is something called phyllosilicates. Now, that's a $20 word for clay minerals, okay? It means clays. And the only way you get clay minerals on Earth or Mars or anywhere, you have to have a lot of water, long time, geologically speaking, soaking those rocks. And the way you form clay minerals on the Earth is you have a rock there, say a lava flow. It's in the water a long time. It breaks down and forms clay minerals. So the lakes I showed you earlier, the water was like battery acid, the pH. But there are still organisms on Earth that thrive in that acidic environment. Not good for us, but some of the things love it. This water here, if you'd have been there about 3 billion years ago, it was on the surface, you could have scooped it up. If you didn't have a space helmet on, you could have drank that water. This is normal drinking water pH right here. That's the only way clays form, in neutral pHs. Clay minerals were not formed in acidic water. So this is important because the climate on Mars was changing in places. It was acidic, and in other places it was more like the neutral pH water. And like I said, organisms can live in both these environments. So this is just what our rovers ended up doing. We ended up driving 28 miles with Opportunity. And to put that in perspective, you think, well, 28 miles in almost 14 and a half years, that's pretty slow. Well, kind of, but we weren't trying to set records. We were trying to do science. And also, there are no roads or paths up there. No one's ever done it before. But we're learning what the planet's about, not trying to see how far we can drive. Anyway, way beyond what we were supposed to do. And you can see some of the slopes we climbed up, pretty much the angle of repose with some of these vehicles. So we did a lot of good work with these things, but as someone said earlier, these are very limited compared to having people up there. The best explorers are people. The best geologists are people. This may surprise you about the speed. The speed of the rover is the speed of a tortoise, very slow. And the Curiosity rover that's nuclear powered goes no faster, okay? And the one that's going to land in February 2021, it's going to go no faster. This is the speed. And in football, there's a saying, you don't outkick your coverage. And Mars missions, you don't outdrive your image coverage because you don't know what's over there in terms of hazards. And then this is probably a kind of sobering thing to think about. That's the furthest we drove in one day. That's still the record, okay? Because Opportunity's landing site was pretty flat and smooth. So it was kind of easy to drive. And you can see in one day, that's all we did, about 219 meters. But these are the major accomplishments. I've already hit on these, so I'll go through that. This is what killed us, the dust storms we talked about. And this is going to be a factor for when we send people to Mars because they pop up, and this thing, by early June, the dust was already starting to go. And you can see by July, the whole planet is enshrouded in dust. And it didn't clear till October. So they last months when they kick up. And they can cause a lot of problems. This is from the surface what it looks like in a dust storm. This is Opportunity in the summer of 2007 on Earth. These numbers here are the number of day on Mars, day 1,205. And this is local time, 11:14 in the morning. And it's looking out at the same landscape. And you see these numbers here as tau. That is called the atmospheric opacity. The higher the number, basically the more dust in the atmosphere. So you can see what happens out there about almost the same time of day in the morning. And that goes from 12:05 to 12:35 day. And that gets bad. The rovers almost died. We were barely able to keep them alive. And the one that came last summer was even worse than this. The opacity got around 11. And that's what killed Opportunity. Couldn't get any power. And the thing about the storm, this storm kind of hovered over our landing site, where our rover was, for a couple of days. And that was enough to drain the batteries. Usually they move on, but that one just kind of hung out. And it killed us off. This is a sunset on Mars. And it's interesting because sunsets on Earth and Mars are reversed. The Martian sky is usually kind of a cinnamon color, but at sunset it gets a blue tone to it. On here on Earth it's opposite, okay? At sunset it's more the oranges and pinks. Well, that's kind of like Mars. So, because it's the scattering of the small dust particles in Mars. And anybody know what this is? Yep, that's the first picture of Earth from the surface of Mars, this little bright pixel. It's a crummy picture because it was taken at nighttime, and our cameras weren't supposed to be working at nighttime. There's not enough light. But that's the Earth, and you know, it's basically just a little bright star, and that's what you're going to see when you're on the surface of Mars. Earth is going to be a long, long way away. Probably have a bluish color to it, greenish, but it's a long way. And you probably know how long it takes for transmissions to go from one to the other. It can be anywhere from 10 to 20 minutes one way, okay, because the distance is involved. And you really can't have a conversation, okay? And this is another thing we've never dealt with, because even the moon, if you go to the moon, it's still so close, it's about 1.5 light second delay. That's pretty much instantaneous. If you listen to the Apollo transmissions very carefully, you can hear that little echo in there. That's that 1.5 second delay in there. Mars is going to be a lot more. It can be up to 20 minutes each way. So hello, 20 minutes you hear it, and then you respond. So that's 40 minutes. You better be saying good things in there. Hello ain't going to cut it, you know. And you're really, for all intents and purposes, going to be dependent on yourselves on Mars. The mission control role that we're so used to on Apollo and a space station, space shuttle, is not going to exist anymore. And mission control will be there to support, but really you're on your own on Mars. And that is something we've never had to do in terms of space exploration. And you're going to have to, not because you want to, it's the laws of physics, you're going to be. And the distance is involved, you can't come home. So this is going to be very different for the people that go there. And let me just talk about more sending people to Mars. There's a lot of things being talked about because it hasn't happened, and there's a lot of possibilities, and it's good to have a lot of ideas. You know, it's going to take, the quickest you can get to Mars is probably about 6-7 months with our rockets that we have today. Some journeys can take longer depending on the orbital alignment. But 6 to 7 months is about the quickest you can do it. And you're weightless that whole time. You're getting exposed to radiation the whole time. Some studies, people have talked about having artificial gravity, you know, spinning a room or something up the spacecraft to create artificial gravity, to mediate the effects of there's no such thing as zero G, it's called micro G, technically. Because there's always some gravity somewhere, it's just such minuscule amounts. The question is, for the human body, since we evolved in 1G, do we have to have 1G, or can a quarter G or a fraction of a G counteract all the bad things you get when you're weightless? You know, red blood cell count goes down, you lose calcium out of your bones, your muscles atrophy, your heart shrinks, you get a little taller while you're up there, your fluids redistribute, all kind of bad things happen to you. And if you could create artificial gravity, maybe you could it could be a good countermeasure, and you could counteract all these bad things that happen to you. The question is, how much gravity do you need? No one knows. No one's done the studies. This is a proposed thing for a Mars mission, is the crew gets in here and it spins. And this is another interesting aspect, something called torpor. Anybody have a clue what that word means? It's cryogenically induced torpor. Basically, it's hibernation. You've seen it in science fiction movies. If you've ever seen 2001, you've seen it. The first Alien movie had it. I know the first Alien movie had it. You've seen these things before. What you would do is put the crew basically in hibernation mode. Torpor is a technical term for it. It decreases your body temperature by about 10, 12 degrees, and that makes your metabolism slow down. You breathe less. You're probably even fed with a tube. You don't need a lot of space. You can be spun in here the whole time to counteract the stuff. This is all hypothetical. No one's done these things to see if it's really going to work. And you can see, you know, do you need only 7 RPMs to counteract it, like the moon, or do you need a full 18? And that 18 RPMs depends on the diameter of the object also. So these are things that need to be studied. But this hibernation thing is interesting because you don't have to bring as much food or as much oxygen. Now, personally, I don't think the whole crew will be put to sleep. You may do it in shifts, maybe a month or 2 at a time. I think you always want to have somebody awake in case something goes wrong that can be alive and alert. Because when you come out of this condition, you're going to be groggy and out of it for a while. And to date, the longest, this technology is being used in battlefield to get people who are seriously injured back to the mobile hospitals and things. But they're not doing it for months at a time. The longest record I've heard is 14 days in China, and it's dubious if it was really 14 days. It's done for hours and maybe a day or two. They pack people in ice and stuff in the Middle East, like Afghanistan battlefield, and get them back. So it works, but we're not sure you can extend it for months at a time. So it's got some things to be looked into, but it's interesting because it could get around a lot of bad things. This is from the movie 2001, and this is 2 crew members were up, and these guys are all asleep in their hibernaculas, they call them. And so it's a way to reduce the weight, because weight means money in launching spacecraft to Mars. And so it's to be seen if it's really going to happen or not. Now, I spent 6 months in Antarctica, and there's a lot of parallels with Antarctica and Mars in terms of the science and the environment, cold, dry, windy. Mars is a lot colder, believe me, than Antarctica ever is going to be. But very similar. The most Mars-like place you can go on Earth is Antarctica, okay? Especially the dry valley areas where there's ice-free regions. And that's where I went. And this was the place we went. And you can see we're surrounded by, this is the South Pole's up this way, surrounded by glaciers, and that's the sea frozen over. But we're out here, we're bare rock and dirt, a lot like Mars. Very cold, windy, dry, and no snow there. But there's certain traits for people who go to Antarctica that I think translate directly from when people go to Mars, and even astronauts today. You have to conduct this field work in really remote, isolated areas, and it's a tough place to be. It's not for everybody that wants to go there. When I was down there, a couple of people freaked out on the science team. They couldn't handle it. They wanted to go home. You're not going home. You go down an icebreaker, you get flown in by helicopter, and that ship goes back to South America. They're not coming, life or death, they are not coming to get you, okay? You sign on for this before you go. So it's a lot of, to me, the psychological part was the toughest part. Physically, you get used to the cold and doing the work, and you want to be there, you're motivated, you want to be there, okay? It's the same thing's going to apply for Mars. People think, oh, I don't want to go to Mars. Well, nobody's going to hold a gun to your head and make you go to Mars, okay? The astronauts that fly today, they're not being forced to go, they want to go, okay? And they realize the risk, and so do their families. This is what it takes to do this kind of work. Because my friend's like, oh, I'd hate to do that. Well, then don't do it. Nobody's going to make you do it, okay? It doesn't work that way. There's plenty of people that would volunteer and do this stuff, okay? Thank goodness. But anyway, some of these characteristics, and you have to be willing to do these things, and the whole time you're down there, and space is even more magnified than Antarctica. Antarctica is a walk in the park compared to going to the moon, all right, or especially Mars. But hovering around you all the time is a specter of death or injury. But you can't think about it because you won't get anything done, all right? And they try to screen people out, but it doesn't always work, who should and shouldn't go. Now, in my expedition, I was down there, it was with the Russians, there was 6 months, and 2 of the Russians just lost it. One of them just couldn't handle the isolation remoteness of it. He wanted out. Well, nobody's coming. Sorry, you're there. And you just better tough it out or figure out how to make it a good time because you're there for the duration. The other one got homesick, missed his wife and daughter. And it's a fine line. You want to remember your loved ones, but you don't want to dwell on it because it's a slippery slope. I would think about it, but you had to kind of shut it off sometimes. You had to compartmentalize because if you think about it too much, you start going down. And the other Russian, he started missing his wife and daughter so much, he was bedridden. He wouldn't leave. He was in severe depression for about 2 months. Then he finally just snapped out of it. When we first heard about it, they said it's his heart. We thought, oh man, if it's a heart attack, he's going to die here because you have limited medical supplies down there. It's basically, for broken bones and stuff like that. We don't have any defibrillators and serious. And we were scuba diving. We had no decompression chambers either. So if something really serious happens, they're going to die. Well, it wasn't a heart attack. It was homesick. His heart was sick. That's what it meant. The translate didn't come across. But we were thinking, oh man. But before we even left, we had to make out our last will and testament, which is kind of a weird thing to do. I was working on my Ph.D. at the time, and because people die in Antarctica every year. And then we had to have a dive physical for the guy doing scuba diving. This was another one here. The Russians don't bring your body back. If you die, they bury you in Antarctica and leave you there. And I came across a couple burial sites because we were the last drop-off point from the icebreaker. We circumnavigated more than half the continent and visited several Russian bases along the way. And sure enough, the graves were there. And they're very shallow graves because of the ground ice. So you had to agree to that. And then we were on the icebreaker for about a month and a half. We even got to our base. So that's kind of like traveling to Mars in a small amount because you're in activity. But this is a picture from a famous space artist. I don't know if you ever heard of him. His name is Chesley Bonestell. Did a lot of famous paintings in the 50s and 60s of space exploration. And this is one you don't see very often, but it's a funeral on Mars. And this is a real possibility when you're going to go to Mars. I personally think the first mission to astronauts go to Mars, somebody will die or be seriously injured on that mission. Because the thinking right now is it's going to take 2.5, 3 years, okay? That's a long time. A lot happens to you even on here on Earth in 2.5, 3 years. And you got to think when you're going to Mars, you're at the very limit of your technology, you know, and things can go wrong. And it's a dangerous environment, unknown. Like I said, there are plenty of people that are willing to do this, though. But this is something I don't know if you talked about in your class, or maybe you haven't got to it yet. Somebody dies on Mars. You leave the body there, do you bring it home if the family wants it? Is there an autopsy? Was it murder? What's going to happen? Well, this is something we never had to deal with, but these are realities. And if you bring the body back, personally, if it was me, I would say bury me on Mars and bring back more rock and soil samples, okay? Because I think, you know, I don't really care if I get buried on Mars or Earth. It doesn't matter. You're not there. You're gone. But other people may want, or the family may want the body to bury, okay? So you have to have this figured out beforehand. You can't make it up on the spot. Maybe the answer is no, nobody comes back. They sign up and you're not getting the body back. Or maybe, here's what to think about. If you bring the body back, where do you put that body? You float by it every day and see your buddy in a little compartment? And what does that do to you psychologically? Do you hang on a tether out in space? But what does that do when you look at the porthole and see it out there? Do you eject it into space, kind of like a burial at sea, and just let it go, like the movie 2001 did? What do you do? These are issues that are going to have to be answered when we go to Mars, because they're going to come up. Okay, if we go back to the moon, as the plans are right now, they'll come up then again. Apollo, we were only on the moon 3 days, the longest mission, okay? So this didn't happen. But when you talk about going to Mars and settling Mars or colonizing it, whatever word you want to use, these are going to happen. And there's an old saying that a place does not become a place until somebody's buried there. Well, anyway, this is our Russian icebreaker. That ship was about 400 feet long, and our helicopter flying out of there. And let me just get through these. This was our base, and we flew in my helicopter. I took this picture. I didn't know what I was taking a picture of. These are a couple of snow banks, but there's debris everywhere. What happened down there? I'm from Alabama. It looked like a tornado hit this place because part of the thing were intact, and other things were off their foundation, gone, and flattened. I didn't want to say anything. I'd never been to Antarctica before, and I was like, I never heard of tornadoes in Antarctica. I didn't want to have people laughing at me, but that's what it looked like. I've seen tornado damage before. And we spent the first month and a half rebuilding the camp. No one had been here in over a decade. No one knew what the condition was going to be. And believe it or not, you need like a freezer because it gets enough above freezing out there in the summertime, and there's 24 hours of daylight to put our meat and stuff in. Well, the meat was pretty crummy meat to start with. From the Russian stuff was horrible, but we went out into a snowbank and buried our stuff out there and kept it cold. And but after a while, it started getting kind of pretty nasty condition. But it wasn't really good quality meat to start with. But these are just lessons you start thinking, now this is easy. This is on Earth, okay? I got all the air in the world I want to breathe. I don't need a spacesuit. I know the radiation's not a problem. And the water, well, I can melt snow and the glacial ice. I can melt that. And there's even lakes there. If you get through the ice cover, you got water there. Some was salty, some was fresh water. But all these basic things are there. And it's easy, but it's a tough place to live. And danger is around the corner because this was a Red Army troop assault carrier with tracks on it, like a tank. And we used that to carry our scuba diving gear, our tanks, compressors, and stuff to where we did our scuba diving hours and hours away. And there's no roads down there, so we would cut across these frozen lakes because they're smooth and you could go fast. Well, one day we hit some rotten ice and we fell through. We were lucky because we bottomed out right there. Other lakes down there were 400 feet deep, and if that would have happened, you'd have a different speaker right now. I wouldn't be here. But we were lucky, and things are going wrong. Our generators went out. This is, like I said, this is easy compared to going to Mars. And this made me think a lot about stuff, because this is probably the closest I'm ever get to going to Mars, is this thing right here. going to Antarctica. And it got me thinking. I've been to a lot of NASA meetings over the years where they talk about the first mission is going to be on the surface of Mars for 500 plus days. And I understand the reasoning behind it for radiation protection and for planetary realignment. I do not believe the first mission to Mars will be on Mars 500 days. There is another way to get there, but all you're doing is really traveling. And in the past it was called a sprint mission. They may have a different term for it now, but all you're doing, you can get to Mars and back in about a year. But you only spend a month, maybe 2 months on the surface. Not a lot of time. The rest of it is just going there and coming back. Not the most efficient use, but I think that first mission will go that way, is to prove it can be done and the people can get there and back in one piece. That's my opinion. You talk to somebody else, maybe something, another thing, but that's my opinion based on some facts, living in a place that's most Mars-like place on Earth, but in a lot of ways is a piece of cake compared to Mars. So, you know, you learn a lot about that, and this was the lake. We did a lot of scuba diving in. I think that's most of my slides, but I kind of want to ask me jumping in. So last slide, then I think we got some time for questions, more questions. This is interesting because there was an abandoned Polish base down there no one had been to since 1968. It's less than a mile from the Russian base. And there was an Australian base about 6 miles away no one had been to, that we had permission from Australia to go over there and we could get solar cells and food. And they had habitats there. They were fiberglass, they called it apples, round red fiberglass domes. If everything, like, if it really hit the fan, we could go there and hang out and just kind of survive. We had their permission, it was their territory. You could have done it without them asking, they would never know, but it's just a polite thing to do, you know. And they said, sure, please use anything over there, just give us a report of the condition of everything. Well, all the candy, the chocolate bars were all gone, all the good food was gone. There are some things left there. The weird thing is they had instant mashed potatoes. The Russians were fascinated by instant mashed potatoes. Why, I don't know, because we had lots of potatoes, but they were like the regular, you know, potatoes. But they were fascinated about the box, had water and mashed potatoes. Like, wouldn't you want to eat a real potato besides all this garbage? But they'd never seen it before, I guess. They were fascinated. And it's a tradition on Antarctica, and probably will go to Mars, I bet, to put signs up of kind of where you're from, how far away it is, where you are now. A lot of these are put up by the previous Polish and Russian scientists. And I was working on 3 signs down there, and towards the end of this expedition, we didn't know when we were getting picked up. That's not the way the Russians work. The Russians say, the ship is coming, be ready anytime the next month. The US program is like, get on the radio, when's the ship going to be here, and you know. Russians don't do it that way. They have different ways of doing things. So the last month we were down there, we had to stay close to the base, because if the helicopter showed up out of the blue, you better be on the helicopter, because it's leaving, and they're not coming back. So I was down at this Polish base, and I heard the rotor blades of the helicopter coming. I took off, and I was working on some signs. One of them was Tuscaloosa, Alabama. That's where I'm from. It's 11,000 miles in that direction. I'm in Phoenix. They messed up. I'll tell you. I didn't finish these signs because I took off and I heard the helicopter coming. And you also had to have all your gear packed up at a moment's notice in your duffel bags to get out of there. Because the weather was, when we left, we got there on the first day of summer and left in the fall, and it was getting 25, 30 below zero, and it was starting to get more darkness hours of night and stuff. Anyway, I didn't finish the sign. About 8, 10 years later, some people went back down there. And I said, you know, when you go, can you do me a favor? Can you finish my sign and tack it up and take a picture for me? So they went down there, and they put them up there, but they messed this one up, because it's supposed to say Phoenix, Arizona. It just so happens there is a Phoenix, Alabama, but it's spelled a little different. But they messed it up, but it still didn't matter. And then I had one for Mars down here. And I thought it was kind of neat. It took a while to get it done, but the guy took the picture and sent it back to me, and they're still sitting there. I guess it's still there to this day, unless the wind blew it over. But there's a lot of parallels with Antarctic exploration, I think, in Mars. The harsh, you know, conditions and stuff. And anyway, that's the closest I ever get to going to Mars. And who in here would like to go to Mars? Not too many. You remember hearing a couple of years ago, it's kind of disappeared now, a place called Mars One, the one-way trip to Mars. You remember hearing about that? It got a lot of media attention. And the company's bankrupt, it's never going to happen anyway. But they were talking about flying people to Mars one way. And it's cheaper because you don't have to bring them home, okay? You just got to get them there. And they had all these volunteers, you know, people doing it. And the way they selected them was about videos. I mean, it's just, the whole thing was a joke. And they were going to sell broadcast rights like the Olympics and try to fund it. It fell apart. It was just a bunch of nothing to it. But a lot of people said they were going to go to Mars one way, and I agree with you 100%. It sounds good right now, but when you drive out the launch pad, they're jumping out. They're not going. Because most of these people had no technical training or background. They were just, anybody could have put the application in and done it. And I'm thinking, first of all, this is not going to work because you got to train these people. Their very lives and each other's lives will depend on this training. You don't just get some Joe Blow and fly them to Mars because he had a nice video. It doesn't work that way. You better hope you're not on that mission if it does, because you're not going to survive. But there's no way it's going to happen, okay? And that's the thing about it, is when the rubber meets the road, a lot of people will not go, and nothing wrong with that. But believe me, there are people that will go. I would go. And man, it'd be so exciting. I'll tell you one thing that happened on this that you can't foresee when you do these things. I've done a lot of field work in these Mars analog environments near the North Pole and down here in Iceland and volcanoes in Hawaii and Arizona, all these places, Alaska. But when you get out there, especially here, to go somewhere no one's ever been before, man, that's a neat feeling. I didn't know it would happen, and it's hard to describe. It's like a drug. It's very addictive, I'll tell you that, because when you go around like this bend here, no one's ever been there. What are you going to see? It's exciting. It's not for everybody. I don't know. I'm just one of these people that like it. I'm not a thrill seeker. I don't do daredevil stuff. There has to be a reason to do it. But that kind of stuff down there, we were going, I remember the Russians expedition leader said, look, we're going somewhere today no one has ever been. We must be careful, and we don't know what we're going to see. That is really thrilling stuff. There's something called Project Artemis. Have y'all heard of that? Well, in March, last March, the vice president gave a talk in Huntsville, Alabama about the plan is to get astronauts back on the moon by 2024. And originally it was supposed to happen in 2028. They wanted to move it up. And I think that's it right here. And the reason, I'm one of the people that think you have to go back to the moon before we go to Mars, okay? There are other people you can talk to that say, no, let's go straight for Mars right now. Forget the moon. It's boring. It's a waste of time, waste of money. I disagree. The moon is in our backyard. It's 3 days away, okay? And if you look at these things, this is an older chart, but it's still, the basic message is true. 1 to 12 months, this is the moon. These early missions to the moon, the Apollo missions, like I said, stayed on the moon only 3 days. Those missions total time was about 12 days from liftoff to splashdown. This Artemis mission is supposed to fly. Artemis 1 will be an unmanned test of this big rocket they're working on. Artemis 2 will send astronauts out to circle the moon and come back to prove the hardware and reentry, heat shield and everything. And Artemis 3 will be the one that actually lands on the moon. And there will be 2 people that land on the moon, the first time since 1972. And they're going to land near the South Pole of the moon. And the reason they're going there is because the South Pole of the moon and the North Pole, there's these craters that are permanently in shadow, and there's ice down there, water ice. And we all know what the value of water ice on Mars, the same thing applies to the moon. If you land on the rims of these craters or ridges, they're in perpetual sunlight. Some of these places are called the peaks of eternal light. So you get all the solar power you want and communications with Earth and light, and you go down into the crater and get your ice. There's not a lot of places on Mars, the moon have that. That's prime real estate. And so who gets there gets it. First come, first serve. So the moon will be a test bed or proving ground for Mars. And it's very close. If something goes wrong, you can get home in 3 days. Once you go out here, you know what happens. You don't turn around and come home. Now, I asked a friend of mine who does trajectory analysis about a Mars mission, how soon, if you send a crew to Mars, when can you turn around and come back and get to the Earth? It's pretty sobering. You have a couple weeks. After that, you're going for the ride because you don't have enough fuel to get back. The Earth is moving and Mars is that far in its orbit. So within a couple weeks, if you have some kind of abort situation or crew medical emergency, you can turn around and come home. I think it's about 14 to 17 days. After that, you got to go to Mars. No matter what happens, you're on the way because you don't have enough fuel to track down the Earth in its orbit. You'll never catch it. So that is something that is very different that we've never had experience with. And so you want to go to the moon to learn how to use this water resource, okay? Because it's simple. Okay, we melt the ice and drink it. Well, how do you do that really? Well, there's a lot of details here. We got to filter stuff out. I mean, there's a lot of things you got to do there. And now another thing, so the moon is close. There's a lot of science here. I don't want to get into that, but just the technology. living off the land kind of type of thing. Learn to do it on the moon. Develop the techniques and the tools that can be used for Mars. Now, to be honest, Moon and Mars have some differences, okay? But there's some commonalities there, and I think you need to learn how to do that before you head on to strike out from Mars. Another scenario thing that's being talked about, and this makes a lot of sense. Before you get there, your crew gets to Mars, they call pre-deploy stuff. Pre-deploy your science equipment, your rovers, your extra food, oxygen, and fuel to come home maybe. Send that out unmanned, let it sit on Mars, maybe a couple years before you ever show up. Build it up. Okay, it's called pre-deployment. And that makes a lot of sense. And that's the way you kind of want to do things in stages like that. And then the crew shows up, and it's like a pre-made home. You're ready to go. Okay, that's best case scenario. Now, what happens if you do that and you rely on that 100% and you get there and find out, uh-oh, we had a leak in the water and it's all gone. You're dead. Okay. Now, granted, you're going to have sensors on there and monitoring pressures and stuff, but like I said, after that 14 to 17-day mark, you're going to Mars. Okay. If it's day 21 and the water all leaked out of your pre-deployed water tank, too bad, you're going to Mars. So the first mission, probably missions to Mars, will have a lot of redundancy. You're probably going to bring all the food, all the water, all the fuel with you. You'll have it at Mars, and you can build that up into food stocks or fuel supply depots, but you don't want to count on it being there and being usable. So you want to bring, I just personally, in my opinion, you're going to take everything with you need to get there, and you probably will pre-deploy stuff. That makes sense. But would you bet your life on it? I don't think we will. I think that eventually we'll start doing these things, build this base up. So these are some scenarios how to do these things. Early on, it was most of these solar-powered vehicles had to be near the equator for more sunlight. But now with Curiosity and the other rover, they're nuclear. They can go further, higher latitudes. Now this is a meeting I went to in 2015. This was the first Manned-Mars Mission Landing Site Workshop in Houston, Texas. And these were the engineering constraints we were given to figure out landing sites. And this is an early sketch of trying to do this. It's going to change a lot before it actually happens. But engineering will give you constraints that you have to abide by, okay? So for this, the technology we have now at this meeting, the landing site had to be plus or minus 50 degrees. You couldn't go any further north or south, closer to the pole. Temperatures are too harsh, and you have problems with orbital mechanics getting out of orbit, getting back to Earth. You have to be at an altitude of less than 2 kilometers. You got to use your parachutes. And if you're too high up, like up on Olympus Mons volcano, you're not going to have enough atmosphere to slow you down. You're going to make a crater. So you have a lot of constraints, your latitude constraints, and this also feeds into the ground ice. You probably don't want to go to the equator because that ice is further down. You got to drill, and drilling is very hard. You have to use parachutes. Now, the hard thing right now about landing people on Mars is these rovers, Curiosity and the one in 2021, they weigh about 1 ton. That is the maximum we can land on Mars right now. We got to figure out how we're going to get bigger payloads down there, because to get humans there, you're going to need something like the 2-story house coming down on Mars. And our technology now can't land that. You think, oh, just make the parachutes bigger and bigger. No, they rip. It doesn't work that way. Our parachutes now are stretching the limit. That's why we don't use airbags anymore, because the vehicles got too heavy. That's why Spirit and Opportunity will last to use airbags, because airbags just can't support the weight. So we have to figure out that, and you want maximum atmosphere to cushion you, so you can use that parachute and your heat shield. This is like our landing footprint, and it would probably get even better because people will be landing the thing. They're in the loop, You want to avoid certain things. You don't want a lot of rocks there. I mean, you want some rocks, but you don't want to, flip over on rocks. I mean, and you don't want it too dusty. I mean, there's a lot of dust on Mars. Some areas are dustier than others. We make dust maps on Mars by measuring thermal inertia. You don't want to go where it's super dusty. You can blow that dust up. It's going to get everywhere. You're going to get all of your equipment into your electrical circuits. This just makes a bad day. So you've got to, the landing site has to be safe to land in, but it's got to be interesting for geology, because you're going to be there maybe for a long time, or going back to that site over and over and over. So these are the constraints that we're given. Now, these are kind of crude because it's an early stage. As it gets more and more specific, what we want, what we want to do, these things will only grow, I guess number one is everybody figured we were all on the same team. We're here to learn about Mars. And you can't have big egos, because everybody thinks their job is the most important. And sometimes you got to take a back seat and say, hey, we got to do this today. You got to be willing to have give and take. And as a scientist, that's sometimes hard because you think your instrument is the most important thing. The engineers kind of think scientists are a bunch of eggheads, and and then scientists think engineers walk around with pocket protectors and all these stereotypes. But you laugh, you make jokes about these things. You have to have a sense of humor, but I think everybody realized we were being given a gift. Once we got both these vehicles on the ground on Mars, and that's really hard to do, we're like, man, the engineers said, we're going to get you off the ground on Earth and get you to Mars. And once we land on Mars and you drive off the lander, we hand you the keys, science team. You take over. And that's what it is. The engineers were in charge to get us on the surface. Once we got on the surface, science decided what to do, but engineers had to support. And we had certain problems that came up, like when we got stuck in a sand dune, because we were driving real fast, trying to cover a lot of territory. We went to the fine-grained sand, got stuck in there. It took about 2 months to get out. And we had to do test bed work. And with the engineers, we had flight spare rovers. We had to cook up a recipe for Martian soil with diatomaceous earth, clay, and flour. Mixed it up and make it like the Martian terrain. We figured out how to get it. Because when problems happen, the last thing you want to do is make them worse. So you want to think about, okay, where is the problem? What is all working? Let's don't do things to make it worse. So let's analyze this problem. Now the rovers, you had plenty of time because nobody's up there running out of oxygen or anything like that. So we took our time to make sure we did the right things. And it took, most of the engineers were in charge of that. The scientists were kind of like, okay, y'all get it fixed so we can start doing our exploring again. But I guess it's, basically understanding everybody has a role to play and no role is more important than the other. It's kind of common sense things, but they're hard to, and like I said, we didn't sit down and plan any of this stuff. It just kind of happened organically. And, but I think it has to go back to leadership if you've got to pick something, because the leadership said our door is always open. If you got a question, complaint, an issue, come knock on the door, let's talk about it. And nothing is off the table. Our science team, we were told, talk about whatever. I don't care how outrageous it sounds, let's get it out there and discuss it. And no one was ridiculed. That's the way the science worked. And everybody was respectful, and that's just, I don't know, I guess we had a good group of people, but it was, I think the leadership kind of set the mold from the start.